Hello everyone. Today I will be discussing about one of the most important topic in the field of statistical analysis of data in the field of research. So whenever you are conducting research in the field of social sciences, psychology, education, etc., this is one of the statistical technique you are using it. Although whatever data you are collecting, you are uh, free to perform the analysis of covariance using SPSS, but it can be done manually also. So I will be discussing how to perform analysis of covariance manually by self calculation, although it will take time, but you should understand what is the steps you have to follow to do it manually. Now when you are using it basically whenever you want to study the influence of particular independent variable on a dependent variable, and you find that there is certain other variables which may influence the impact at that particular time. If those variables, those who can produce who can influence the dependent variable, that one you have to control, and then you try to study the impact of independent variable on the dependent variable. So we will try to understand that. I will take different examples. You will be able to understand then what I am actually explaining. So let us see how to perform analysis of covariance. Now you will be basically in this particular video you will be understanding what is ANCOVA, analysis of covariance. Then when you are using the analysis of covariance, already I told you what are the conditions, but I will again explain when you are going to use analysis of covariance, what are the assumptions before you are going to use analysis of covariance. Certain pre-required conditions should be there, then only you can use analysis of covariance. Then we will of course discuss the steps of performing ANCOVA manually, and then we will take some examples so from which you can understand how you are calculating analysis of covariance. So let us see. The analysis of covariance is a statistical technique used to compare means among groups while controlling for the influence of one or more continuous covariates. ANCOVA combines elements of both analysis of variance and regression analysis. So let us try to understand. Whenever you try to compare different groups based on the dependent variable, and you want to see that if the difference is there before the condition and after the condition, or different groups are significantly different or doing significantly different, and you found that there is certain other variables which may be influencing the effect created on the dependent variable. So if you have to control that particular other variable which is called as covariates. For example, suppose you want to see the effect of teaching method on achievement of the students. Now you just try to understand that socioeconomic status can be one covariate. So covariate socioeconomic status, if you are getting the values of different students, that will compose of covariate, and you will control that, and controlling that you will be able to see the actual effect of the method on the dependent variable achievement of science. So this is the cases where you are using analysis of covariance. These covariates can be more than one also. Socioeconomic status can be a covariate. Then suppose duration of home study. Suppose how many hours the student is studying at home in the evening, that one is one socioeconomic status. So that one also you can control. So in these particular cases you are using analysis of covariance, and it is composed of the technique of analysis of variance and the regression analysis. You can watch my video on regression analysis and analysis of variance, so you will understand that particular methods also. ANCOVA examines the influence of an independent variable. So what I told, influence of an independent variable, on a dependent variable while removing the effect of the covariate factors. So whatever covariates are there, that one you will control, and then you will see the actual impact of independent variable, which I told you. Suppose teaching method is independent variable and you want to see its impact on the achievement. So, and you are controlling the covariate socioeconomic status, duration of study, like this. If you are controlling, then you will be able to see the actual impact. So in these cases, popularly you are using analysis of covariance. Many a times, also suppose you are doing experimental study. So experimental study, many a times you are not able to match the group on the basis of certain covariates. Suppose their intelligence test score or their uh, previous achievement test scores, that you are not able to control, or you are not able to match the groups. So if you are not able to match the groups, it is a quasi experimental design. So at that particular time also analysis of covariance may be used, so that you will see the actual impact of independent variable on dependent variable. You must have, whenever you are studying experimental research, here also you must have heard that for controlling the what you can say, for removing the threats in experimental research, analysis of covariance is one of the statistical technique. So there also you are using analysis of covariance whenever both the groups are not similar in the pre-experimental condition, before the experimental treatment. If you are seeing that you are not able to equate the groups, you will use analysis of covariance as one technique, so that you can study the actual impact equating both the groups at the pre-experimental stage by statistical method, which is ANCOVA, and then you will be able to study the actual impact of independent variable on the dependent variable. So there also you are using analysis of covariance. So it tests whether there is a significant difference between groups after controlling for variance explained by covariate. So it tests whether the groups are different after controlling the covariates. Suppose I gave you the example of experimental research, when both the groups are not same. You are thinking that before the experimental treatment both the groups were not equated. Then what you can do, suppose you have taken a pre-test. So that pre-test score, we suppose which may be different for both the groups, then that pre-test score can be a covariate, and controlling or using that covariate, you can see the effect on dependent variable, that is post test score, using the technique of analysis of covariance. So whatever pre-existing differences will be there, that will be controlled using the analysis of covariance, and we will be able to see the actual impact of the teaching method on their post test score. So in that way it used to work. A covariate is continuous variable that correlates with the dependent variable. Of course it is correlating with dependent variable. That means that pre-test score is quite related to the dependent variable, the post-test score. So the covariate is a continuous variable. Already I told you the covariate, pre-test scores can be the covariates, and it is quite related to the dependent variable. This is one way that you can run a statistical test with both categorical and continuous independent variables. So categorical are the different groups. You want to compare the different groups on the basis of their post-test score, and the continuous independent variable is the method whatever you are using. So this is one way that you can run a statistical test with both categorical and continuous independent variable. Example is assessing if there is a significant difference in test score among 3 schools while controlling for student socioeconomic status, which I already told you that if you want to compare the test score between the 3 groups or 3 schools, test scores are different or not, while controlling the student socioeconomic status becomes one covariate. So socioeconomics you will control, and then you will try to see the impact on the achievement score. So if you are assessing that there is significant difference between the test score of three different schools, then here also the socioeconomic status of the students can serve as covariate. So here you are able to see that three different schools, that three different categories you are able to see, and you want to see the difference in that group's achievement test score. So achievement test becomes the dependent variable and covariate becomes socioeconomic status. So increase statistical power by reducing within group error. Example, in a clinical trials adjusting for baseline health metrics. So within groups, whatever variance is there, that one you can adjust here. So here also it is applicable, and adjust pre-existing difference in non-randomized group. Example, comparing teaching methods while controlling for student socioeconomic status. Already I told you that you want to compare the why already I told you that if you want to compare three different teaching methods or two different teaching methods while controlling the socioeconomic status, that is also the case, and it also reduce the within group variance. Within group variance. Example, in a clinical trial adjusting for baseline health metrics, suppose all the groups, first you want to make it similar at the baseline so that you can see the effect of particular drug on the health of the different groups. Then to make the similar pre-existing condition before the implementation of the drugs, at that time also you may use this analysis of covariance. So in education, evaluating teaching methods while adjusting prior grades, healthcare testing drug efficacy while controlling for baseline cholesterol levels. Suppose in the groups for which you are trying to study the effect of particular drug in reducing blood pressure, then the cholesterol level can be a covariate. So cholesterol level, if you want to see that if it can be equated statistically, then analysis of covariance can be used, and then you can see that how the drug is impacting the blood pressure. So in that way it can be used. So what is the assumption whenever you are going for analysis of covariance? These are the assumption. Observation within each group must be independent of each other. That means you are taking individual data, you are not correlating one data to other or taking second data based on the finding of the first data. All the group data is quite independent. Suppose blood pressure you are measuring, all the blood pressure measure will be taking independently. So second condition is homogeneity of variances, homoscedasticity, that you say that whatever the group values you are getting, different type of blood pressure measures you are taking. I have taken the blood pressure as an example. Our achievement test, you are saying that variance across the group means variance in one group should be similar to the variance in the other group. It is not that a particular, let me take you an example. Suppose one group of students are there, those who are having from a particular international school, and one school students achievement you are taking for study that is totally belonging to a very poor background school, then the variance will be quite different, and you cannot compare both the groups on the basis of method. So you have to see that the group variances are quite similar, then only you can compare. Then normality, the residuals, the difference between the observed values and the predicted values, of course it is connected with regression analysis also. So you must be knowing in the regression you are calculating the residuals. Residuals is the difference between the predicted value and what is actually there in the calculated value. So that difference should be normally distributed. Linearity should be there between the covariate and the dependent variable. So these particular variables should be linearly dependent, or linear relationship should be there. So socioeconomic status, and then I told you achievement of the students. It quite, you can see that this linear relationship is existing. Now take one example. Suppose one scenario is there, you want to assess whether there is a significant difference in the mean exam score of students from three different schools. Three different schools are there, A, B and C, and you want to see the mean achievement score is different or not. And here socioeconomic status becomes your covariate. So because socioeconomic status will have some influence. So here you have got group A, group B, group C, means are there, sample variance is given, and the sample size is there. So socioeconomic data you have to collect, and then you can go for analysis of covariance. So this is one of the case you can use analysis of covariance. So what will be the null hypothesis here? Null hypothesis, there is no significant difference in the means of the exam scores among the three schools after controlling socioeconomic status. An alternative hypothesis is there is significant difference in the mean exam score among at least one pair of schools after controlling, because you are controlling socioeconomic status, you are taking socioeconomic status as a covariate. So you perform an ANCOVA to determine if there are statistically significant difference in mean scores among the schools while accounting for socioeconomic status as a covariate. So this is one example where you are using analysis of covariance. In this way only, this type of, if situation is there, you are using analysis of covariance, and then you will be able to see the actual effect occurring in between the groups. Now let us see the steps how you are doing the analysis of covariance. So there are few steps. This is one of the way to calculate analysis of covariance. You can convert it, you can do it directly also, but steps will be more and the calculation will be more complex. So to make it simpler, you have to go for this particular step where you are using this correction term. If you are not using this correction term, then the calculation will become little difficult, because you have to go by after taking the actual differences, and then your calculation will become little complex. So what you are doing, the correction terms, I will tell you the steps, and once you will solve a particular problem, you will be able to understand how you are doing this particular calculation. So first step is you are calculating the correction terms. So correction term, suppose here I have taken example for the variable y, and this is for adjusting the grand y. Suppose that y is your dependent variable, and that or post test score. So to adjust the grand y is total sum of all the y's, all the within all the groups. Among all the groups if you are taking together, correction term is summation of y, then square of that term divided by n. So that is the correction term, summation of y, all the y you add and square it and divide it by total n. Suppose you have got three groups, in each group 5 participants are there, so total n will be 15. Total sum of square is sum of square total is y square you will do, and then sum it, all the y square means all the variable y will be squared first, then added all the in all the groups taking together, minus correction term which you have got here. Then among group, which is also called between group variable variance, among group which is also called between group variance, means when you are comparing one group to the other group. Suppose three groups are there, three methods you have used. So if you are comparing these three groups, there you are comparing this among group is summation of y1 square plus y2 square plus like that. You add and divide it by n minus cy, that correction term for y, whatever you will calculate here, this one you will use. Then error variance within groups means for each group, within that group the values are different. So here also if you calculate error variance or within group variance, you have to use this formula. So that is given by within groups sum of square y is total sum of square, which you have calculated here, minus among sum of square. It is, you can write here sum of square among. Sum of square among is this one. Sum of square among is, so you subtract sum of square among from sum of square total, then you will get within sum of square or the residual variance or the error variance. Now adjusted sum of square total, so adjusted sum of square also you have to get, because you are using covariate here, and then you have to see that what is the sum of square after adjusting that covariate, after controlling that covariate. To total sum of square will be total sum of square y, which we have got here using this formula, minus total sum of square xy. X is the covariate. Till now you are not seeing any covariate here. All this calculation you have not seen any covariate, but for when you are adjusting the total square, for that only you are using analysis of covariance. So once you are using x as a covariate, you will calculate total sum of square x by using this formula, total sum of square y minus total sum of square xy divided by total sum of square x. This will give you adjusted sum of square yx. Now degrees of freedom for the residual group, the error group, is n minus k minus number of covariates. N is the total number of n. I told you total means all the groups taking together. What is the total value? That is n. K is number of groups that you are comparing, and number of covariates here. Suppose number of covariates only x, you are taking one covariate is there. Suppose 3 groups are there, number of covariates is 1, and n is, suppose your total n is, in each group 5 participants are there, total n is 15. So 15 minus 3 minus 1, that is 15 minus 4, 11 will become your degrees of freedom for the error variance. So in that way you are calculating the degrees of freedom for error variance, and then you have already got the among group variance, or this between group variance, that is k minus 1. So k is 3 minus 1 is 1. So among groups, because groups are 3, so 3 minus 1, that is 2. 2 will be your among groups or between group variance. So these are 2 degrees of freedom, because here you have to see 2 degrees of freedom. One, you can see this F formula. One is between or among group. So between group degrees of freedom is k minus 1, and this adjusted mean of square within is degrees of freedoms are this one, and minus k minus number of covariates. Then you will get the F value, and then you compare to the table, and you will get that the result is significant or not. So I hope this table you have understood little bit, but you will be able to understand once I will be calculating, taking one example. So let us do that one, then you can understand what this table is talking about. So this is one hypothetical condition. Suppose that 15 children are there. Suppose 15 children have been given one trial X of a test. 5 are then assigned at random to each 3 groups. Then the 5, one group is being praised, one group is scolded, and one group is the control group. So if you want to compare these 3 different groups, group A, group B, and group C, and your covariate is X. X is the covariate. X is covariate. X is covariate. Then how you are able to do that one we will see. So 5 are then assigned at random to each of the 3 groups A, B, and C. After 2 weeks, say group A is praised lavishly, group B scolded severely, and test repeated on one test, that particular test that you have given earlier, that one is repeated again. So at the same time, a second trial was also given to group C, the control group, without comment. And group C, it is a control group, you have not done anything. two groups already you are using treatment of different type. One group is being praised, other is scolded, and third group is just your control group. So for this particular table, these values are here already written. The same test scores after this particular treatment Y1, and for group B after scolded treatment Y2 scores are there, and in Y3 third group also the scores are there. Now just try to see what else you can see in this particular table. You have got different sums. X1 sum is there, Y1 sum is there, X2, Y2 sums are there, and you have multiplied also X1 into Y1. So that is also required. So means also you have calculated. X, Y, these means are there, and how you are calculating that you can understand. 60 divided by 5, 110 divided by 5, like this. So for all the three groups, summation of X is 185. If you will add this all to 15 plus 10 plus 20 plus 5 plus 10, then it is becoming, or you add these three things, 5, 5, 10, 5, this 60 plus 75 plus 50 you do, then you will get 185. 60 and 5, 110 or 75. Like this, if you add this summation of Y, similarly, this 110, 80, or you add this 30 plus 20 plus 25 plus 15 plus 20 plus again 28 plus 12 plus 20, then it will become 255. Then summation of X square is you are squaring this all term. 15 is squared, 15 square is 225, then 10 square is 100, 20 square is 400, like this. 5 square is 25. You add this all, then you will get the sum as 2775. And similarly, you square these terms, you will get the sum as 5003. And then you just don't square this, you just add this term, because already two terms are there. X1 into Y1 already has been done. So you just add this one, 1425, 1317 and 750. If you add, then you will get this 3545. So this all you have calculated as per this particular table and this particular step. Now coming to this step 1, correction term. Now the correction term, as you have already seen the formula earlier. So the correction term for X is, this is the first step. This way only you solve. The first step, you just square the sum of X divided by N. Square the terms of Y divided by N, which is correction of Y, and for correction of term X, Y, it is sum of X into sum of Y divided by N. So where N is the total of each different group. Example, total in X group is 15. All details taken, all the values together across the group, that is 15, 5 in each group, so 15. So Cx is 185, that we have calculated. Sum of X was 185 square divided by 15, 220, 220, 282. Similarly for Y, similarly for correction of X and Y. You just try to see, is it not summation of X into Y, it is summation of X into summation of Y divided by N. So these all are the correction terms which you have got. You have used this particular term and you have used these two particular term has been used, not this one. You don't have to use this summation of XY, because it is summation of X into summation of Y, not summation of XY, and N you already know it is 15. So this is the, you have in first step you have calculated the value of correction of X term, correction of Y terms, and correction of XY. Now in the second step you calculate total sum of square. Total sum of square is summation of X square, all the X square which you have summed, already you have done in the previous part which I already told you, minus correction term of X. Total of sum of square Y is sum of Y squares minus correction of Y. Total sum of square XY is sum of XY minus correction term of XY. So putting these values, you just see it is √775, you got summation of x square, all the x squared sum minus correction of x, that is 493. Similarly, correction of y is all the y square summation minus the correction of y, 668, and total sum of x y is, you have already calculated, sum of square xy minus subtraction is correction term of xy, so you have got 400. So this first in the first table you have already got this total sum of squares which was there, correction term you got in the first step. So using that you have calculated total sum of square x, total sum of square y, total sum of square xy. So you have used these two values, and also the third value, summation of x y is this 354. This is the value of summation of x y. So this one you have used here you have used. You can see this value was here in the previous slide, it was here, you have already seen. This value you have used, this value you have used in the total sum of square xy. So this way you have calculated total sum of square. So this is step 2. Now coming to step 3. So in this step 3 you have to find out among group means. So you have got total sum of square. Now we have to got among group means. Among group is you are comparing one group to the other group. So here the among group sum of square is, this is the formula, summation of x1 square plus summation of x2 square plus summation of x square divided by n minus cx. So here n is 5 because you are comparing one group to other group. So in each group 5 participants are there, so n will become 5 minus cx. Similarly, assumed sum of square y is sum of square of y1 square, sum of y2 square, sum of y3 square minus correction of y. And similarly, as sum of square xy, among sum of square xy is x1 y1 plus x2 y2 summation of x3 y3 minus cxy. So and I already told it represent total in each group. So now you put the value. The first value is, if x1 sum you take it was 60, I think so. So square that one, it is 3600. Similarly, all other terms. First, second was I think 75 it was. So it has become 5625, and then 50 was there. So 2500. And this correction term you have already got. So this is the among sum of square x. Among sum of square y is similarly like this only you have calculated. So it has come 210. And among sum of square xy, you have to do summation of x1 into y1. So you just multiply 60 into that first x1 sum was, that one is multiplied. The among group and the among group sum of square xy is using this particular formula, summation of x1 into summation of y1, that is first one was 60 and this one was let us see what it was, 60 into 110 plus 75 into 80 plus 50 into 65. So that one you all add and divide it by 5, minus correction term of xy is 3145. So you got 25 as your among sum of square. So you divide it by 5, subtract some correction term of xy. So this one will become 25. Now formula for, now you have got total sum of square, you have got among sum of square. Now it is quite easier to get within sum of square or the error sum of square. That one you will get it using this formula. Within sum of square is total sum of square minus among sum of square. Then within sum of square, total sum of square minus among sum of square, which is also told as between sum of square also. Among sum of square is also told us between sum of square. So within sum of square is of xy is total sum of square xy minus among sum of square xy. So you put the values 493 minus 63, 430 you got, then 458 you got, and 375 you got. So and using these values, using these values which you have already calculated earlier. So using total sum of squares and among sum of square values, you calculate within sum of square values. So this much is quite related. These all things you are doing when you are performing ANOVA also. Although there is only one variable, one set of variable, you are just trying to compare this. You are calculating total sum of square, you are calculating among sum of square, and then you are calculating within sum of square, and then you are doing using degrees of freedom, you are calculating mean sum of squares, and then you are getting the F values. From here you are going to the actual calculation of ANCOVA. So now you will calculate the adjusted sum of square, because now you are taking covariate as covariate x here, and then you are trying to calculate the adjusted sum of squares of y's. So that you will see now. So now in this particular step, actual ANCOVA analysis comes into play. So you will get the adjusted sum of square. So you have to get the total adjusted sum of square, within adjusted sum of square, within or between, and then you have got among adjusted sum of square. So total adjusted sum of square is using this particular formula, total sum of square y minus total sum of square xy square divided by total sum of square x. So this is this formula you will use. So just try to see, it is total sum of square y minus this total sum of square xy square divided by total sum of square x. So let us see these values which we have got from here when you calculated this total sum of squares. So total sum of square y is 668. You will be using this 493 also, and you will be using this 400 also. So you will use these three values 493, 668 and 400 to calculate the adjusted sum of square total. Just try to see, 668 was total sum of square y minus this one was 400 square is this much divided by 493. So you have got total adjusted sum of square 348. Similarly, within adjusted sum of square is all you are doing for y only, because you have to see the difference in y. So within adjusted sum of square y, then within sum of square xy square divided by within sum of square x. So you see these values just now we have calculated here. This is 458 here. This 458 will be using, this particular thing you will be using, and this 430 will be using. Using these three terms, you will be calculating within sum of square. So putting these values, we have got within sum of square, adjusted sum of square, and then you all know that to get the among adjusted sum of square, you just subtract from total within. So you will get this one adjusted among sum of square is 212. So in this way, taking these values, you can see these values are here only. From here, from taking from here, which I was showing you, you have calculated this, and taking these all values, you have calculated this, and then this is just subtraction of this value from this particular value. So you got all these three values: total, adjusted, within adjusted sum of square, and among adjusted sum of square. Now as you have got all the values which is required for calculating an analysis of covariance, now we will go to the table for calculating ANCOVA. Now I already told you that for degrees of freedom, it has got 2 degrees of freedom. One will be among or between group degrees of freedom, and other will be within group degrees of freedom. So among group, the formula is k minus 1, and within group it is n minus k minus number of covariates. This is number of covariates. If it is more than 1, it can be 2 also, 3 also. So here number of groups is 3, so k minus 1 is 3 minus 1 2. So degrees of freedom is 2. Just try to see 2 is written here. Here also it is written. And within group degrees of freedom or the error variance is n minus k minus 1, that is n is 15 minus 3 minus 1, that is total 4, so it is 11. And these values we have already calculated: sum of square x, sum of square x for among group, sum of square for within group 430, then sum of square y for among group and then within group, then sum of square xy is also there, 25 375. This all we have calculated, but basically we have to use this one for calculation of mean sum of square, adjusted mean sum of square. So 212, that just now we have calculated, 212 divided by 2, it gives you 106, and this within group mean adjusted sum of square is 131 divided by 11, that it gives you 12. So using this formula we have calculated these two things, these two factors. Now f will be the ratio of mean sum of square among divided by mean sum of square within for adjusted means, and the value we have got 8.83. Now if you see the table value, the critical value at 2, 11 for f at 0.05 level is 3.98. Now 3.98 is quite smaller to the calculated 8.83 value, so the framed null hypothesis has to be rejected, and you can say that the group differ in their performance when you are adjusting the covariate with pre-existing differences. So in this way you are calculating ANCOVA. So you have to follow these all steps. Already 5-6 steps are there. If you will go in systematic manner, then you will be able to calculate ANCOVA manually. So ANCOVA enhances. So finally we can conclude that ANCOVA enhances precision by controlling covariates, but requires strict assumptions. That assumptions which I have already talked about, that has to be strictly followed, then only your calculation will be correct. Ideal for quasi-experimental design in education or healthcare. I already told you that it is used in quasi-experimental design whenever you are not able to match the groups. So you can use this one to control the pre-existing differences. Always validate assumptions. So I told that assumptions you have to validate, and then only you can interpret the findings. So I hope you have understood how to calculate analysis of covariance using manual technique. What are the steps of calculating analysis of covariance? The correction terms, if you will calculate, which I have explained, it will make the task easier. Otherwise, if you will work with the actual differences, then the calculation will become little complex. But this is quite easier. That one only I explained, but you can always go with the actual differences also, the actual values differences also. That one also you can do, but doing this thing is quite, doing this way it simplifies the task and it makes easier to calculate it using the correction term. So I hope you have understood this calculation of analysis of covariance. So if you like this particular video, please subscribe to this channel. Keep learning, keep growing, keep sharing. Thank you.